So enterprise DevOps. I'm going to try and take you through what actually you heard a couple minutes ago in GE, where they explained how their path over the past year seemed to go, went from starting in an organization, getting it through to everyone that is at the higher different levels of the organization, but eventually creating a support network inside of various different silos, business units, of people that understand DevOps, that understand Chef, that understand how to deploy applications. So let's start. This presentation, there's not going to be any code in this presentation, unfortunately. I would probably get fired. As soon as I get back to Washington, they'd kill me. But it's going to explain the work that was required to introduce DevOps into a large organization. Unfortunately, we weren't able simply to just say, yes, let's turn DevOps on, let's install Chef. Let's not worry about security, compliance, proxies, firewalls, none of that fun stuff. But we're also going to talk about how DevOps is going to provide value for business. We needed to make sure that we were able to talk to business, talk to upper management and R&D, talk to product, and how DevOps will deliver better value to what they're paying for our customers so they can utilize it. So let's go through here. These are the bullet points. Bloomberg is an organization. I'm going to talk about Bloomberg. For those of you that don't know Bloomberg, you'll know a little bit more after today. Differential diagnosis. Exactly what was the problem with the current situation? Bloomberg's culture is actually very similar to DevOps in some ways. But why didn't it work for web in particular, but the rest of the firm? How do we introduce DevOps? What were the actual steps that we had to take to introduce continuous integration, to introduce the culture, the sharing, the communication? Starting a web operations team, that's what I'm part of. I have a couple of my members back there. You raise your hands if you want to talk to them. But in general, what does our web operations team actually do? Why did we create it? Why couldn't we just use the policies and procedures and just create a nice facade on top of it? And finally, what I like to call battle stations. This is actually implementing all the things that we told upper management and promised them. We're going to do this. We're going to make it better. Well, let's start making it better. So a little bit about myself. Right now, Bloomberg doesn't really have titles, but I guess you can call me the technical lead of Bloomberg Web Operations. Pretty much, I sit in meetings. I curate the backlog for the web ops team. I came from New York City originally. I started at Bloomberg as equity derivatives engineer. So I started in finance, what most people think of when they hear Bloomberg. And from there, I moved down to Washington, D.C., where some of our web products were. And I worked on that team as an application service developer for a little while. I got into the DevOps role probably about a year and a half ago, maintaining our servers, making sure deploys and provisions were going properly, maintaining the continuous integration pipeline was greased, everything was working. I got my C programming experience writing code for MUDs. How many of you know multi-user dungeons? Yes. So I'm proud to say I have code in the Smog MUD engine, which is Realms of Despair. Yeah. So Bloomberg, the organization. So for those of you, again, that don't know Bloomberg, we are not a bank. That's one of the three things that I get, the misunderstandings about Bloomberg. We are the largest financial software and data organization. At least that's what the marketing materials say. We're a heavy engineering culture. Actually, most people don't know this. We're a technology company, technology information company. In fact, what you're seeing right here is our brand new keyboard. We built it from scratch. There's a video on our website, bloomberg.com/about. There's a link to how we built our brand new keyboard. Most people, what they do know about Bloomberg is how colorful the keyboard is, and it looks really inviting. Well, that keyboard's actually unique because it has a fingerprint sensor on there. It has a charging port in the back for our biometric two-factor authentication unit. We build custom hardware. That's one of our R&D areas. But we also, obviously, are a large software company. We have a corporate culture that, by definition, promotes collaboration. In fact, we designed our elevators in a way that you need to go up several floors. If your target destination is 20, you got to go up to 23 because we want people to strike up conversation in the elevator, strike up conversation down the staircase. But ultimately, we're an information technology company. We're a well-oiled machine. We have an amazing corporate culture. Our technology cross-section is crazy. And I'm going to talk about the web properties. But one cool thing is that we have hardware that most companies dream of. In fact, web developers are foaming at the mouth knowing the hardware we have. So let's go on. The well-oiled machine. So again, I mentioned that we're the largest software data and information provider, but we primarily provide workflows and software on top of our data. We provide what's called the Bloomberg Core Terminal. That's our core business. But all that financial software data, it actually gets distributed several mediums, not just the internet, not just the core terminal, but the television, the radio. We actually have one of the largest private networks in the world. Each one of our clients gets a individual, we call them circuits, basically individual line run to their office so that it's a private network. It's secure. We know it's secure. Well, at least before OpenSSL. But, well, that aside, our R&D actually builds internal tools for all facets of the organization, for news, for television, for the internet, the terminal, the radio. Again, we have about 3,000 engineers. I think it's actually slightly higher. Primarily located in New York, New Jersey, and London. I'm one of the satellite offices of Washington. And our corporate culture is unique. So what about our corporate culture? We've been around for about over 30 years, if I can count. There's about 20% of the employees are under what we would call an R&D organization. They might not all be engineers. We actually group our ops, our operations, we group our systems and infrastructure under R&D. And application developers are grouped under R&D as well. So it's a mixture of basically all the technology expertise in the company. Efficiency and high availability is in our namesake. In fact, the one time that I know of that the Bloomberg went down, it was on the front page news of everywhere. In fact, the Bloomberg goes down, the stock market stops. Our time to market for our core terminal customers, we value that very, very high. In fact, we optimize to get to the market as quickly as possible and iterate from the initial, software product we deliver. And again, part of an organization that grew organically in the early 1980s, where there was no internet, there's a lot of operational, homegrown technical solutions, let's call them. So let's get a little bit of a technology cross-section of Bloomberg as a whole, not specifically web properties. We have what we call big iron, little iron. We have big iron machines that run Solaris and AIX. Our little iron machines, we have RHEL. We have RHEL and Ubuntu, CentOS. We have Windows. These are server machines. It's a mixture of physical and virtualized hardware. So we do use OpenStack. We use VMware. We virtualize both Windows and Linux. We have a dedicated team to cloud infrastructure, researching, contributing back to OpenStack. Because of all that, our core terminal, we dog food it. Everyone uses the core terminal for pretty much their day-to-day activities, email, whatnot. So a lot of the services that everyone takes for granted, PagerDuty, things like that, we've already built them. In fact, they're built into the terminal. So what we do need to do, though, is integrate some third-party products that we use, OpenStack, VMware, GitHub Enterprise, and we need to make sure that they interact correctly with the core terminal services. And again, we have multiple architectures. So we do need to think about, Little Indian versus Big Indian, x86, 64, Power, Spark. We have all of them. And we have an ARM cluster somewhere that we're testing too. I don't know if I was supposed to say that. So let's talk about the web properties, because that's the cool stuff. Consumer and subscription web verticals. So what does that actually mean? Consumer verticals, you're probably the most familiar with. Bloomberg.com, BusinessWeek.com. Businessweek, obviously the magazine, that's a separate part of the organization. But they have different traffic patterns than our subscription verticals. Bloomberg.com is a typical news site. It gets bombarded with news, probably in some kind of daily graph, so 9 o'clock, 12 o'clock, depending on when people are watching the news. We have a lot of storage that we need to use for origin media, so video, radio, things like that. The subscription sites have kind of an opposite side of traffic pattern. Very finite number of customers that we know access the service, but those customers do heavy workflows on sometimes the client and the back end. And we need to support ETL jobs. We need to support large amounts of data coming from the terminal, which is, you could pretty much consider it a fire hose. And we need to denormalize it, put it in a database and whatnot. So we have a homegrown application service architecture very similar to protocol buffers. It uses data center affinity. There's from data center A, if a request originates from data center A, it's going to get service in data center A if there's an available service prior to jumping over data center B or C. And the service-oriented architecture also has different types of load balancing and routing. So let's go into a little bit of a differential diagnosis. So we have the first way we actually did this is we created a support network around our web verticals. We put people we call representatives on each team that had the technical expertise in their domain, particular area, that we could trust them with mapping the infrastructure that they depend on, the build infrastructure, continuous integration infrastructure, to what's actually critical in their business. We made them highlight the inefficiencies, and we started a culture where those application representatives present it to each other, and we started sharing. We call them deep dive sessions. They happened about a year ago. So let's talk a little bit about after we had this, we were able to identify, catalog all of our assets, infrastructure assets, and we knew where we had to attack, where we could strengthen some things first. So our brittle foundation. So like everything else, there's a lot of shoestring budgets. We have a culture of homegrown technology. So a lot of the core infrastructure is owned by the application teams themselves, especially because the web properties grew about 20 years after our core business. So things like Redis, things like Ruby Gems, NPM mirrors, those are all owned by individual application teams, often without the knowledge of other application teams. So they might start relying on infrastructure that isn't the primary business goal of those application teams. The implementations are often seen as good enough. They're running on 1 or 2 servers. They synchronize with rsync maybe every 15 minutes, things like that. Several teams depend on these assets in the organization, but they don't have clear owners. And that's a big problem because that presents a significant business risk. Because, for example, if the Ruby Gem server happened to go down, well, all of our Ruby products can't build. In fact, because they're not allowed to go out the internet because of firewall and security rules. So we knew we had some support difficulties. Our application infrastructure was not standardized. People that are running Ruby, maybe running Ruby Enterprise Edition, Ruby 187, Ruby 193, maybe the newer teams are running Ruby 2.0. They may be running separate patch versions. Although we do have a security team that keeps our patch versions up to date, sometimes the app teams need to basically request that the Rubies are being updated from major versions. We had several of the app teams orchestrate their own solutions, create their own solutions for Redis failover. So between 2 data centers, what's the best way to fail over Redis? There's at least 3 at Bloomberg, and I know there's at least 2 more on the internet. I don't know the answer to the one that's the best. I know the answer to 3 that work. But more importantly, we have strict deadlines that drive decisions that most of the time are against what we would call our policy. So policy for deployment, policy for an SLA. But these deadlines tend to go around what we would call standard procedures. Let's talk a little bit about server procurement. So in our organization, certain virtual machines are treated as physical machines, depending on the services that they're consuming. So that means monitor and telemetry infrastructure, Nagios, some other homegrown things. They're set up for physical machines, and often there needs to be scheduled window of maintenance for some configurations to be updated. Configurations of these services has sometimes an unknown lead time. Maybe it'll be a day, maybe it'll be a week. We don't really know. Self-service tools are currently available through our terminal that we dog food to start virtual machines. But not all web verticals have people on the team that are knowledgeable enough to use them and use them to their full potential. And firewall ports, network policies, they don't go across VLANs. So each time we create a server, if it's in a separate VLAN, you have to go through opening a firewall port. It's not the ideal. But we do have a healthy dose of the fear of the unknown. Since our company is very successful, core business is very successful, there are policies in place that just haven't been updated because they work. Network policies, we don't revisit them. We don't really think about innovation until we're forced to. Maybe in some case because we're introducing a new vendor. Maybe because we have a new project that needs to be separated from the regular network traffic. But more importantly, the web properties are a different model than what we call the core terminal. They heavily use open source software. They use Ruby gems. They use Node. We require GitHub.com access to our dev machines for testing. And it's actually different, but we use Mac development hardware. Our organization, before web properties, they didn't even know how to configure a Mac because they didn't have to deal with it. So all the policies for provisioning a physical machine for a developer to actually work on aren't in place. So let's introduce some DevOps. Let's talk about the problems that we identified in the Bloomberg organization and how we were going to solve it. We can talk about the processes, we can talk about the policies, but more importantly, we want to facilitate experimentation. We want to let developers experiment. We wanted to focus on solving the real problems, but not re-architecting solutions that were actually good solutions. There are really good solutions that we had. But more importantly, we want to share and communicate amongst all the teams, amongst externally, that's why I'm here. So, the culture. We're no longer going to tolerate fighting amongst internal groups. We're going to lead with questions when we're in meetings. Have your list of questions, lead with the questions. Make sure that the people that you're talking with are the right people. Don't bring people that don't need to be in a meeting into a meeting because you're interrupting their productivity. But most importantly, I'm going to use what's become a Chevism, make a fucking decision. At the end of a meeting, make a decision. The goal for everyone in our firm is to get quality products in front of our customers as quickly as possible. Simple as that. If we're not on board with that goal, then we need to figure out what we need to change. But we also want to aid to make the organization, we want to use this as an aid to make the organization a better place for developers, a better place for experimentation, creating products. And we want to solve the problems and not punt them to another team because that's just putting them on someone else's backlog. So let's talk about continuous delivery. So we actually had continuous delivery in some of the web groups at Bloomberg well before we started this DevOps initiative. The problem is that they use different types of technology. One team used TeamCity. One team used Jenkins. One team used homegrown shell scripts. That worked. They all worked. Were they the right decisions? But we want to standardize our continuous delivery pipeline using Chef. We're going to use Jenkins to build a wrapper cookbook. We're going to expose resources and providers that allow app teams to build on the fly, build pipelines, depending on the type of app that they want. Maybe you want Food Critic if it's a cookbook. Maybe you want JSLint if you're using a JavaScript Node application. We're also going to provide hooks into the GitHub Enterprise instance that we run. And we're also going to hook the GitHub Enterprise instance up to all of our enterprise services that we use for those different functions or applications. That's a Bloomberg lingo. Applications that everyone uses to manage the infrastructure. Pull requests should work just as they do outside the firm. It's an organic conversation to create better code. And more importantly, teams should not care if they're running on Jenkins or if they're running on TeamCity. If we do it the right way, they should only care about GitHub. Does it give me green? Are my tests green? We're going to store all of our artifacts in a distributed storage file system that's exposable over S3. We call it Ceph, but it's on our OpenStack cluster. So, continual improvement. We want to measure the metrics that actually matter. Mean time to failure, mean time to fix. We want to use that data to make decisions instead of just using the data to point fingers. We want to train each of the teams, each of those representatives that I mentioned earlier, how to use the tools that we actually build appropriately. How to diagnose problems so that early on in chain of command, if you want to call it that, tickets that can be easily solved because it's a junior developer, they can be solved by the representative on the team. We want to learn from all of our mistakes and we want to teach. But we want to create a feedback loop. Application developers, if there's a problem, a legitimate efficiency issue, they should be able to come to us and say, listen, John, we need to fix this. This is too much of pain. We want to communicate and share all of our problems with both internal and external teams. So sharing and caring. Again, our company is often misunderstood as a bank. And I think part of that is that, up until recently, we haven't really been sharing and caring as much as we should. So we're here to talk to the external world about our problems, about problems we've solved, about problems that we don't know how to solve. A lot of the business units in the web teams have worked in verticals. We call them verticals, and that's a horrible name because that implies silos, and that implies that completely different than everyone else. But we want to reuse the patterns that are developed, the patterns that are we call standardized, because it allows us to give optimum support. It allows us to be as quickly as possible, deliver an application, start up a virtual machine, provision a Redis node. But we want to also trust that the policies that those teams put in place were there for a reason. They didn't just create a policy to create a policy and impede us. We don't want to go around authority. We want to figure out the right way to do it. But we do need to question policies and decisions if we think they're wrong. That needs to be in the culture. So this is our web operations team. We call it Team Duct Tape. It's a cross-functional team that we built, a small team that we built amongst the areas of expertise. So security, platform, infrastructure. We're responsible for building and adapting the chef recipes to our infrastructure and make everything automated, data center operations, things like that. So we're going to go through each of the person's roles and why we chose who we chose. So we were a Tiger team chosen specifically due to our expertise in certain areas. We're tasked with the ownership of web infrastructure, web application infrastructure more importantly. We build reproducible, reusable software patterns so that every application team in the firm can use the same patterns and that there'll be a deterministic result. And there'll be application wrapper cookbooks for each of what we call the software stacks, Java, Ruby, Node, things like that. We're going to provide software as a service almost, Redis, RabbitMQ, those style of things that application developers need. But we're going to take ownership of the continuous delivery pipeline from start to finish. So let's walk through the app engineers real quick. Technically, that's me, responsible for the backlog direction. Security engineer, responsible for overseeing the policy decisions and implementing those policy decisions in Chef. Platform engineer, responsible for VMware and OpenStack expertise, but implementing the integration of cloud services with the orchestration that we use to provision our virtual machines. And infrastructure engineers, these are application engineers that were on the application teams in the verticals, and they're intimately familiar with the pain points, the inefficiencies of the current process. So it's called Security Mastermind. He's actually back there if you want to raise your hand. He's responsible for overseeing the security policy of all the web infrastructure. He's got an intimate knowledge of the existing process, if he likes it, better not. He provides a key role designing all these wrapper cookbooks that we're talking about. Understands the good and the bad. Deep knowledge with internal security and policy requirements. The reason why, in some cases, we did a decision that may not seem so great now. Currently developing chef recipes for a Red Hat satellite server that we need for our omnibus packages that we're building. HA Proxy and Apache cookbook wrappers that we're using. Our platform czar, fortunately he's not here, but he has a knowledge of enterprise integration. So how our enterprise services, our tools, integrate with the cloud services that VMware provide. He has the expertise with our vSphere version. I actually don't know too much about it, but do we have high availability? Can we actually snapshot a running virtual machine? Actually, these are all the questions I ask him because I don't know him. I don't have time to read up on all that. He focuses on building what we call a compatibility layer between our different cloud providers. So we are rolling an OpenStack cluster. We want to make sure that all of our chef provisioning, all of our orchestration that we build is going to work on both OpenStack and our VMware cluster. Should be able to start new virtual machines, start the networking, creating VLANs, automatic firewall rules. Storage. So our storage, we want to attach storage to a virtual machine. That's done through a volume. In OpenStack, it's a Ceph-based volume. On VMware, there's a VMware volume. And he needs to be able to manage the tools that he builds needs to be able to manage snapshots and scaling. So our infrastructure ninjas, this is actually what I think the coolest job. But they're sourced from all the web application teams, so they have intimate knowledge writing different code. So Ruby, Java, Node. They have knowledge of all the inefficiencies, as I mentioned earlier. They know where the roadblocks are, where the log jams are going to happen. But more importantly, they have ideas how to solve the problems. So They're tasked with building the integration between our GitHub Enterprise services and building a self-service platform that we're going to allow, similar to Heroku, where our developers would have push button, create a Redis instance, or deploy a new application. They would see their GitHub project similar to Travis CI in that self-service. It would tell you how many times it failed, things like this. And these project dashboards, we want to abstract away the CI bit. We want to abstract away the lint. Using different GitHub APIs, we can pass or fail a build if a security audit passed, or if it was just a lint that passed. We could still pass a build if lint passed. So let's talk about battle stations. We want to solve the easy problems first, so we get the maximum gain, the maximum benefit. We have to break habits, and breaking habits is a very, very hard thing if anyone's ever tried to lose weight like me. We don't want to jeopardize the speed or the business growth. So we move really, really quick, and we need to make sure that our application developers, our business, can still move at the same speed. In fact, we want to move them faster. And we need to be able to support technology changes, technology pivots, where they need to be done. And documentation, of course. That's at the bottom, though. So low-hanging fruit. Reusable software patterns. We want a single way to deploy a Redis server. We want a single way to deploy a telemetry server with Logstash, with collectd, with Zabbix. We need to be able to fix the log jams that exist right now. We need to take over some brittle web infrastructure. We need to start streamlining the process for creating new procuring new virtual machines. Start creating automation for configuration validation. So each one of our configurations that a web developer wants to use, we put it through a validator. We can use Chef Solo for that. They can use JSON payloads, and we can output a Apache or HA proxy configuration that we know is security compliant. But we also took ownership over our Mac development workstations. We have simple scripts that install the appropriate certificates, root CAs, that are actually in our corporate for various internal services. We set up proxies, we set up Vagrant, we set up VirtualBox VMware, depending on who you are. And we provide this image to all the web developers so that if they ever have a problem with their Mac, just image their machine in 15 minutes. So breaking bad habits. We use GitHub Enterprise to enforce the pull request model. All code actually must be signed off by a technical lead or someone that actually owns the project that you're submitting pull requests to. Test failures are going to be visible to every member of the team that owns the project. The problems with virtual machines or in the environments, they need to go away. So divergence of configurations or drift. Wrapper cookbooks will take care of that. We'll allow them to fine-tune some of the knobs. Applications can no longer be treated as snowflakes. Sorry, you're not unique. But we need to investigate the issues as an application team using our representatives, our support network, prior to dropping a ticket into operations or infrastructure, because that just stops our process. That stops it's unplanned work. So we need to support fast business growth. So we're going to do this using our self-service panel. We're going to allow developers to click a button, get a Redis server, click a button, get a MySQL database, automate all that, including DNS. Operations infrastructure should not be the roadblock for business growth. That's one of our key principles. Management of the systems should be officially supported by the developers themselves. So a certain number of developers, those key ones that we talked about, should be able to go on their machines and make break fixes if they need to. Hot patches, some organization would call them. Teams should understand the migration path from their current infrastructure to what we're building, the platform that we're building. And the patterns should be made easy just so people can get shit done. That's all we want. That's all they want to do. That's all we want them to do. And we need to streamline our best practices so that applications can be deployed quicker. So, rapid technology pivots. This is the cool stuff. We're using OpenStack. We're using Omnibus to build full stack installers for all of our application platform stacks, if you want to call it that. So Java, different versions of Java. But what's great is that using GitHub Enterprise, we can enforce the patch release of that version of Java, Java 1.8, patch U56. Developers should not be able to say, I want a specific patch version. In fact, that's a security decision. But developers should be able to say is, I want Ruby 1.9.3, I want Ruby 2.0, I want Ruby 2.11. And we achieve this using Omnibus, which will install packages in parallel for both Debian and Ubuntu, or Debian and Red Hat. We use Packer to build disk images for CentOS 6.5, 5.10, Ubuntu. And we bake the Chef client into it so that we don't incur the cost of using Omnibus to install it every single provisioning. We install our custom certificates that are necessary for our internal services. And we harden the disk images with the Yum upgrades and package updates that we expect. And again, the way that the self-service infrastructure is set up, we're going to allow developers to use Vagrant with a couple of custom plugins that we will be open sourcing. And a lot of the actual runtime configuration of a node or more specifically an instance will actually be done through Cloud Init. So, documentation. Because we have GitHub Enterprise, we're easily able to use Markdown to make everything nice, GitHub Wiki and Pages. The Wiki we're using for standard operating procedures, onboarding information, and Pages are going to be used for tutorials, basic setup. They can even be used for teams outside of R&D if they need to read something. Configuration for workstations are now very, very easily visible because we're able to say, here are the steps to get Vagrant working locally on your Mac. And the appropriate plugins are right there in GitHub. So it's self-documentation. So let's talk about what I like to call breeding superheroes. So we have about 300 people or so that are in the web departments. And each team has who we would call a technical lead, or we're calling them a support representative. And these individual people in a large organization, you need people that are at ground zero that understand the domain and can fix the problems as quickly as possible. They're our first line of defense for unplanned work for operations. They're going to know that there simply was a misconfigured Apache directive and it stopped Apache from loading, instead of ops taking an hour or two to figure out whose configuration that is and what's going on. We also need to be able to train these individuals. We need to host internal training sessions for the technology and deliverables that we build. So our support network. They're identified by the technical contributions that they've already made during the discovery process that we talked about earlier, the deep dive sessions. They're the representatives that are already considered all-stars or superheroes. Escalation of issues need to go through them now. Rather than dropping a ticket in operations, infrastructure, systems, it's going to go first through your representative so that they can vet to make sure it's an actual issue. But more importantly, they're our first line of defense. They're our partners in crime, if you want to call it that. As our first line of defense, they're the people, again, closest to the problem domain, but they also ask the basic questions to the developers that are having the problems. Did you start Apache? Did you read the logs? These are things that we would have to ask instead, and the feedback loop would be a lot longer. Allows us to limit the number of unplanned work episodes as an operations team. But it also gives us the ability to do a lot of pre-diagnosis of problems because of our ticketing system that we won't have to do again when we're actually, as an operations team, figuring out if it's a network or a firewall or a proxy problem. All that data that they've already tested, verified, is easily available. So, leveling up. So we offer monthly training sessions that correspond roughly to what our deliverables will be. The future projects and services that we will offer a first glimpse, and we'll get the feedback necessary. It's part of the sharing. The representatives will have the capability of saying, hey, you need to fix this, or this isn't going to work for this reason. But more importantly, we created a community amongst all of our developers, amongst all of our representatives that are now at the ground zero level of all of our app teams. And they're promoting DevOps, they're promoting Chef, they're promoting all of our infrastructure, all of our platform that we're building. So sharing. GitHub's treated as a source of truth for all of our infrastructure, all of our code, all of our Chef. The pull request model, again, is used as a conversation, not just code review. It shows the evolution of features, the evolution of infrastructure. Because of rebasing, it'll squash commits, and some of the reviews will go away. The reviews are happen because of the relevant partners, the relevant web operations, systems or infrastructure teams. And continuous integration will build these packages, build these artifacts, and deploy them, once successful, to our S3 back storage. And again, ultimate goal, providing holistic solutions. So that's all I have. I figured I'd take some questions for the last 5 minutes. I'm going to have office hours 2:30. I think it's in one of the rooms over there. But feel free to talk to any of my team members. 3 of them are sitting back there right now. They're going to raise their hands. And the rest of them have Bloomberg on their badges. Thank you.
Okay, there you go. I thought it was an excellent presentation. One of the things I'm fascinated is the culture of the pull request model. Mm-hmm. And I think there's been a lot written about that and how that way of thinking.
That was me.
That's me, I think. Oh. It becomes a great model for doing infrastructure in general. Yeah. Could you just give me a little more of that and your experience of how you kind of took that? Because I think that's a key of how we change culture in the enterprise, is nailing that.
Yeah, absolutely. So about a year ago, we introduced GitHub Enterprise. It's been great for the application developers. We've recently, in the past 2 or 3 months, started with infrastructure. So I guess the best explanation I would give is that Will over there created a Vagrant plugin to automatically update our CA certificates on whatever guest virtual machine that's running. And that's going to be open source soon. But more importantly, when he created it, Will didn't know a lick of Ruby. In fact, he was asking all of us, hey, is this the right way to do this? Is this the right way? Through a combination of chat and pull requests, we were able to suss out all the problems that the plugin would provide. In fact, it allowed us to give a better product to our customers, which will be all of you, as a Vagrant plugin. So it's great. I think the only issue that we've run into is that sometimes, and this isn't particular to our team, but it's very hard for some people to get, personalities don't always shine the best through text. Let's put it that way. So it's not a complete replacement for talking and face-to-face communication, but it is very, very, very good for code reviews and infrastructure. Yeah.
Hey, thanks for the talk. What are the other challenges you're facing? So you've gone through this kind of transformation. What are the next things that your team has got to knock down?
This is a great question. It's kind of a little bit of a lie because we haven't gone through it yet. This is actually, we're about the beginning stages. So we're at the point now where everyone's bought into this. I hate the word buy-in, like you mentioned, paid forward. We're at the point now where we're building the chef infrastructure, and we're hoping by the end of the summer, we'll be at the point where we can actually have the ability for a self-service panel for customers to start doing this. At that point, it's going to move a lot more towards the cloud provider end, where we need to support on both VMware and OpenStack. So right now, we've been testing mainly on OpenStack. We're going to need to support all of our providers, eventually bare metal. So a lot of it is being reactive to what the developers need. So they're being proactive, we're reactive to what they are. But a lot of it's also going to be a lot of porting a lot of existing infrastructure to wrapper cookbooks, so services and whatnot. Yeah.
Thanks for the talk. One thing I'm interested in is because I saw a lot of different OS names dropped. How are you guys handling patch management? 'Cause I'm guessing there's thousands of servers.
That's an excellent question. I got to be very careful how I word this. So we have teams specifically for patch management for different types of software. So we have a team specifically for patch management for compilers, team specifically for for operating system service, so AIX or Solaris. We work with all of our vendors, so generally they get the patches for us. For software such as OpenSSL, it usually falls on the shoulders of the teams that in the specific areas, so let's call it web, there's a team called web security, which is kind of being changed into my team. And basically we use Omnibus right now, but prior to that it was an RPM that they would do, and it would be pushed out to a satellite server and used like CF Engine and updated it depending on what where the server was in the network. Yeah, it wasn't bulletproof, but it works.
How did you solve, the networking gear with?
I can guarantee you I have more DMZs than probably everyone in this room combined. We didn't really solve the networking problem. We're kind of piggybacking on the OpenStack effort. So most of the networking issues were solved prior to the inception of web operations, but kind of during the whole discovery period, where we've made some decisions on how we're going to do firewall and load balancer upgrades in the future. And that's all through automation. So there specifically will be automated ways to upgrade firewall and load balancers. Cool.
Thanks. How are you guys doing Windows Server configuration management?
Yeah, that's a great question. Right now, we do Windows configuration management using BladeLogic, BMC. I imagine because of the number of our servers, it probably doesn't really make sense for us to, the web operations team, to take over that management because we don't have any Windows servers. But at some point, I imagine it'll dovetail into using Chef. But right now, BMC works great, or BladeLogic works great for that. Yeah.
I think what's interesting in your story is that you're a financial company, and at the same time you're like more like a startup company as well. Here you have a big R&D department and so on. So I'm wondering how this communication happens between a team that wants to use a brand new technology because they want to be at the edge of the technology, and being a financial company, thinking about like minimalizing the risk from that technology. How does that work?
Well, I can tell you the first way it happens, and it's usually by downloading it on your local workstation. Developers tend to, experiment as they should, just using whatever they can grab off the internet. If it's a new technology, it goes through our web security teams, because in general, they've been the team that builds the packages to distribute it to our beta and production machines. In the future, as of now, it's going to be Omnibus packages using Chef or wrapper cookbooks, and it'll be done through pull requests.
Is there some kind of approval by an architect?
Yeah, sorry, I missed that part. Yeah, so we have a CTO office that approves different open source technologies. Generally, it's permissive based on the license, so as long as it's not, GPL 2 or AGPL, we're pretty lenient. Yeah. Cool. All right. Of course. Alex.
So you said you weren't going to share any code, but you forgot to mention the GitHub repo. So is it still public?
Oh, yeah, you're right. So github.com/Bloomberg, we do have open source code right now. We have a Chef cookbook that is currently being re-architected, but a Chef cookbook that we use to deploy our OpenStack clusters with Ceph distributed file systems and whatnot. And there's a couple other things there as well. And I have a couple of cookbooks that I've developed that are under my name. So if you, at the bottom there, Twitter and GitHub, you see a bunch of cookbooks that I developed. Will's going to be releasing his cookbook probably next week if we're good. Yeah, when we get back to London. Well, he gets back to London, I get back to Washington, so. Cool. Thank you.